Alright, so welcome to Chapter 7. What we're going to do today is begin to look at properties of powers. Remember that a power is made up of a base and an exponent, so I have this little part here that will help you if you ever need to do it. The base is always the big number, the exponent is the small number, and the whole thing is called a power. So again, sometimes we end up confusing the word power for this, but that's actually an exponent, and the whole thing is called a power. We've worked with exponents before. Mostly we've looked at the fact that exponents are an expansion of multiplication, and so we learned that whenever we have n to the sixth, that what it means is that you want to multiply m 1, 2, 3, 4, 5, 6 times. But that brings us to our essential question, which is what makes zero and negative exponents so special to work with. And what it is that that expansion system doesn't work when we apply it with x to the 0 or t to the negative fifth, because it doesn't really, naturally fit what we're used to or what we kind of learned when we first started working with exponents. And so instead, what we're going to do is analyze the patterns with actual numbers and with a calculator. So this is actually in your notes, so just go ahead and follow along with this, write out whatever is there, or you could work it out on your calculator to see. And the good news about this is, if you remember what we're doing right now, if you're ever taking a test or a quiz and you forget what the rule is, just use your calculator and see what happens, because you can use your own inference and your own pattern recognition to kind of go from there. But if you type in 9 caret 0, because remember the caret is your power button, the little up arrow, but if you did 9 to the 0 power, you get 1. If you do 4 to the 0 power, you get 1. And if you do negative 118 in parentheses to the 0 power, you also get 1. And so using our calculator on that, it helps us to remember or to understand that any power or any value to the power of 0 is going to equal 1. Now that's not always going to be the case, especially with variables. We'll talk about that. But again, the main thing about this is that the power of 0 pretty much just takes off everything and leaves us with something very simple. Kind of like what we talked about, 0 being the easiest number to multiply by. 0 is also the easiest power to evaluate because it just ends up being a 1. Alright? But what about the negative exponents? That's kind of different. So again, if you remember this whenever you're taking the quiz, at least that way you can think your way to it. So what you do is you look at 4 to the second, which we know to be 16. So we would naturally think that 4 to the negative second is negative 16, but that's not the case. 4 caret negative 2, again, you might want to type this in for yourself so you know, ends up being 1 over 16. And 1 over 4 to the negative second, again using the fraction button here, is 16. So what's going on here? What I know for a fact is that 4 squared is equal to 16. And so notice when I do 4 to the negative second, that the 16 I have actually ends up on the bottom of the fraction. And whenever I take this 4 to the negative second and move it to the bottom of the fraction, the 16 actually ends up being a regular 16. And so what I get from that is that potentially that negative actually moves the number to the bottom. So let's see that real quick. So 5 squared is 25, which would mean that 5 to the negative second should equal 1 over 25, because again, that's going to move the number to the bottom of the fraction, which it does. It also means that if 7 squared is 49, that 1 over 7 squared, 7 to the negative second, should be a 49, but the 49 is going to move to the top, which makes it a regular 49. Alright, so again, 7, I think I typed in the wrong one. Actually, no, I did the other one. I just kind of forgot for a second. But anyway, what that pattern helps us do is understand that any value with a negative exponent moves it to the opposite side of the, and I'm putting fraction in quotes. You're going to see a few quotes in this because the words I use are kind of to help you understand, but it's just something to kind of help you see what's really going on. When I say opposite side of the fraction, what I mean is this is a regular number, but if you remember, that number is like being 4 to the negative second over 1, and this represents a top value, which means that once that negative is there, the answer that we have actually moves to the bottom. Just like here, the 4 to the negative second is on the bottom, and even though it looks like a regular 16, it's actually a 16 over 1, which actually moves it to the top. So again, you don't need this over 1, you don't need that over 1, but it's important that you understand that a regular number, even like this, represents a top value, and that the bottom moves to the top when it's negative and the top moves to the bottom when it's negative. All right. In order to apply this to higher level problems, we have to learn how to kind of visualize these as a series of connected. Again, here's another print or quote. We have to visualize as a series of connected parts. What I mean by that is, and you want to write this in your notes so you can always come back to understand that this is where a lot of your rules come from. This expression is made up of a negative. It's made up of a 5 squared. It's made up of a e to the negative 6th. It's made up of a f to the 0. And it's made up of a g to the 9th. And what you want to learn to do is to simplify each of these parts individually when you get your answer. What people tend to do is they just try to do all this stuff together, and they try to do all these things, and they actually put the negative with the 5, which, although it is connected, it's really not, because remember, that's a negative 1 attached to 5 squared, e to the negative 6, and so on. But so today, you're going to have some problems on your Math Excel that tell you to separate it into boxes, and this is what you're doing. Just remember that the negative goes in its own box if it's in front. There is a difference between a 5 to the negative 2nd and a negative 5 to the 2nd. That negative is not the same as the negative up there. And that's why I need you to make sure you understand where the negative is, or what the negative is, and what it's really asking you to do. So, if you're asked to simplify this, again, what you're going to do is you're going to look at that first part and say to yourself, h to the 15th, h to the negative 15th is a negative 15, which means that this is a negative exponent, and the negative exponent wants to move it to the opposite side, which means that h to the 15th actually goes down here. Your second part, j to the 23rd, is regular, so it just stays up here. Again, both of these are top values because there's no fraction, so h is on top, j is on top, but the fact that h has a negative exponent moves it down to the bottom. And this is what you would type in, or this is what you would use as your answer. On this one, again, your first part, m to the 14th, is a regular m to the 14th. That's a regular number. That's a regular power, or a regular exponent. So therefore, m to the 14th stays exactly where it is, as it is. But the second part, p to the negative 15th, because it has a negative exponent, wants to move, and so p to the 15th comes down again, and it's a positive 15 because once it moves, it's where it wants to go. Again, a negative exponent means that it's happier on the other side. So this is unhappy on the top, so we move it to the bottom. And like we did on the other one, if it's on the bottom and negative, then you move it to the top, and it's happy where it's at there. So again, a negative exponent means move it to the opposite side. All right. So looking at C and D, these are the ones that are really the toughest because of the fact that people kind of forget to work them out the way they do. And so I'm going to do this like your homework on the Math XL is going to ask you to do, and even if you're not on a Math XL type of class, it does help, especially when you start to do what I did in that connected parts portion of your notes, which is to first off separate this. Your negative 18 to the 6th, c to the negative 3rd, t to the 0, y to the 4th. And you eventually learn to visualize it that way, but again, this is pretty much what you need to see. So the first thing we need to see is the fact that that negative is there. Then we see that 18 to the 6th is a regular 18 to the 6th. We also know we're going to have a fraction here, so I'm going to put 18 to the 6th up here. We see c to the negative 3rd, and again, that c to the negative 3rd is a regular c to the 3rd, which means it's going to move down here. T to the 0, and here is where I said about the rule about the 0 power leading to 1. T to the 0 does turn into a 1, but you don't really put a 1 in this portion, and 1 times that is just there. So really what happens to any variable to the 0 power is that it just goes away. Because remember, this is saying that I have 6 18s. This is saying that I have 4 y's. This is telling me I have 0 t's, which means there's no need to bring it down like that. And then y to the 4th, being a regular y to the 4th, stays on top where it was. This is the answer that you have. Now, your computer is set up to where the negative can be in front of the fraction. It can also be with the 18, but just like regular math, you will never put a negative on the bottom of a fraction. You can put it in front of the fraction or on top of the fraction, but never on the bottom. But that is all you're being asked to do in this section. Now, again, there are more things coming up, but in terms of your first section for Chapter 7, this is all it's asking you to do. So as we look at D, again, we're going to separate this into parts. We have a negative. We have 6 to the negative 11th. we have an a to the 7th, and here's where you have to be careful. Those two letters are not together. That is just a b, and that is a c to the negative 5th. Alright, and so whenever you see this like that, b c to the 5th is b to the first power, because remember we don't put the first power, but that's what we're looking at. And again, this negative here in front just means that they're going to have a negative fraction. But now what we see is that 6 to the negative 11th means that this doesn't want to be at the top anymore. It wants to move down here. Our a to the 7th is a positive power, so we just put our a to the 7th up top where it belongs. Our b is regular, so we put our b right there. But our c to the negative 5th, again, is a negative exponent, which means that c to the 5th wants to go down to the bottom. And that is what we are looking at when we work out that type of problem. Okay? So your final thought on this is more advice, because if you're like most classes, the chapter that you just got out of put you in a bad spot. And if you don't know this book yet, chapter 8 is challenging, chapter 9 is challenging, chapter 10, if you don't get chapter 9, is challenging. I'm sorry, if you don't get the second half of chapter 8, could be challenging. It's just a lot of stuff coming up, and chapter 7 is probably your easiest one, and so I need you to make sure that you get the most you can out of this. This chapter requires instinctual memory. What that means is you have to memorize it, work to memorize it, but not only that, you have to make sure that you know exactly what to do when you see what you see. And so because this represents 2 sections, or 2 properties out of 7, and those things have to be executed, what I'm putting here is naturally and correctly. What that means is you see something, you naturally know what you're supposed to do, and you correctly execute it. That is where we get where we need to be. Do not make sure you're not in a position to where you see something and you accidentally put something in the wrong spot, or you accidentally, going back to this, as people like to do, you accidentally bring down c to the negative 5th as c to the negative 5th. That is not a correct execution of that rule. And so that's where I say you have to make sure you know what you see, you have to make sure you know what to do when you see it, and you also have to make sure that you do not do it incorrectly, because that is honestly what costs you points on assessments and tests, is that small little mistake that you didn't practice out of your system. So refusing to practice usually causes people to misread or choose improperly. My best advice for you in chapter 7 is that if you approach, and actually for the rest of your algebra year, is that you approach every lesson as if it is of the utmost importance. I know it's repetitive, I know it can get boring, but again, the repetitive part happens because you're doing something that is fundamentally important. The boring part only happens whenever you keep getting it right and very easy. So if it's boring because you keep stumbling through it, that's not boring, that's called challenging. Boring means that you're at the point where you can see 10 questions and you can answer them like it's nothing, back to back, no stops, no pauses, and no mistakes. That's what you want to get to. You want to do it repetitive, you want to be boring, or you want it to get boring to you, and that's when you know that you're ready for that test. So other than that, like I said, make sure you work as hard as you can to get this chapter started right. Again, I know a lot of you are probably in a spot where you don't want to be, and it's up to you to work your way out, because that's pretty much what you have to do in the real world. So good luck.